So here's another write a program or write an algorithm question that will be the sort of thing in paper one. So this is a triangle identifier, basically identifying what's an isosceles, or which triangles have at least two sides that are the same. So if we input 3 lengths, then we need to check those lengths to see which ones are the same. Now, I've added a bit to this one to make it so we're using a function for this. So I'd like you to write a function that returns true if it's isosceles and false otherwise. So we'll use the function as part of your program. So this just makes it a little bit more tricky perhaps, or something to think about a bit more. So you need to write a function, then you need to get the inputs from the user and output eventually whether it's isosceles or not isosceles. So this is a bit of a longer program perhaps to write, but it's definitely not beyond you. You'll be good at doing this. You just need to take it a step at a time. So if you want to pause and have a go, at least writing the definition first, have a go at that first, and then have a look at the answer. So first thing I'm going to do is write the definition. So I'm calling it isos, and it needs to take 3 parameters, which are going to be length 1, length 2, and length 3. So we need all the lengths in this as parameters, so in they come for us to use. So then I'm going to return from this false or true. So we're going to have I'm going to call it isoso, just so that it's different to the definition name. We'll make that false as the beginning. And then we need an if statement for this, obviously. So if side, oh, it's not side, is it? Sorry, it's length. I was going to call them sides in my head. Length 1 equals length 2. Or length 1 equals length 2. So length 3. Or if length 2 equals, so we need exact equivalency here, don't we, equals length 3, then we're going to return, we're going to say isoso equals true, and we'll return that value. So we've written the definition. So all this could be on one line. It would be on one line. I just can't fit it on the screen when I'm writing. So it's absolutely fine to write it like this if you can't fit it all on in the exam. Don't forget these are double equals. I almost forgot that. It's double equals here, exact equivalence. If this is equivalent to that, length 1 equivalent to length 2, or length 1 equivalent to length 3, or length 2 equivalent to length 3, that should cover all of the options. So that can be just one statement in your if statement there. Then if that's the case, we're going to make this variable to be true, and we'll return the value of it from here. So we've done the first bit, which is to write the definition. So then we want to get some inputs. So let's call them sides this time. Side 1 is equal to integer input side 1 And we're going to do the same thing for the other ones. We can do it this way. Side 2 and side 3. Integer input. So we're doing integer to convert these two integers, so we're dealing with numbers. Side 3. So we've got some inputs, so then we need to use the definition. So let's call it is isos equals our definition, which we called isos. And then I'm going to send it these sides. Side 1, side 2, and side 3. So notice, of course, they don't have to be called the same thing. So in here they're called length 1, length 2, and length 3. In here they're called side 1, side 2, and side 3, and that's fine. They all map together. So this will map up here to length 1, and they'll just map to the right order. So is isos is equal to isos side 1, side 2, side 3, and then we just need to say something like if is isos is equivalent to true, print. And what we need to output, it says here, is isosceles. It was a difficult one to spell, that. And then we can just go with an else, because if it's not true, it must be false. So else print not isosceles. And so we've made use of our definition here that we called isos with the 3 lengths. So we've checked those lengths and returned a value true or false. So we made use of it here by calling that function. So when we call a function, we're calling a function by allocating the value of that function to a variable. So in this case, is isos takes the value of whatever returns from our function we called isos. We're sending it the 3 parameters that we've got the inputs for. And then if the result of that, if is isos is true, then we're printing isosceles, otherwise not isosceles. So a bit of a longer one to write there because it's using the definition. It might be slightly further than they'll ask you to go in the exam, but we can't guarantee it. We don't know. This is an old question where they just asked you to write a piece of code, or actually they just asked you to write some pseudocode in the old days. But this is a good way of doing it, and it gives a little bit of practice of actually utilizing a function.